Okay, so I'm going to make 6 videos about organic chemistry nomenclature. And the first one is about hydrocarbon compound skills. And it's that first reading that you have to do. It's also based on the basic knowledge of organic nomenclature. So the first thing that we should probably talk about is that in organic chemistry, there are 3 types of bonds that we have to be familiar with. We have the single bond. Oops. We have the single bond. We have the double bond. And we have the triple bond. Okay. Now, a hydrocarbon that has a single bond, that has a series of single bonds, is simply referred to as an alkane. And the ending is super important here. So in this case, we have the alkane, and it has 4 carbons in it. In the double bond, it's a special kind of hydrocarbon that is known as an alkene. And that alkene tells us the fact that there's a double bond located. It's somewhere in the hydrocarbon. And then lastly, the third type of hydrocarbon is called has a triple bond, and it's called the alkyne. And that tells us that there's a triple bond present. So in order for us to name these hydrocarbons, the first thing that we have to remember is that we are looking for the longest continuous chain of carbon. And in this case, the longest continuous chain of carbon, in the case of the first one, has 4 carbons long. And I'm going to number them. 1, 2, 3, 4, or 1, 2, 3, 4. Now, the direction in which we order them, right to left, left to right, does matter later, but for the beginning here, it doesn't really matter as much. So I know it's a 4 carbon long hydrocarbon, and there's all single bonds present. So I know that it's some type of an alkane, and that's its ending. Now, the other thing that we have to remember is we have to remember that there are prefixes that tell us the number of carbons that are present. And those in the reading, so like 1 was meth, 2 was eth, and you should probably know this. 3 was prop, 4 was bute, and then 5 was pent, and 6 was hex. Oops, and the rest is things that we're used to. So in this case, I'm going to name the first one, and I'm going to say that it is a 4 carbon long chain, which makes it a butane. So that's the stuff inside of lighters. And then for the next one, the one with the double bond, I'm going to again number the carbons from left to right. 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. And so I know that there's 2 things I know. One of the things is that it's an alkene. So the ending is going to be ene because of the double bond. And then I know that it's 7 carbons long, and I know that the length of the carbon chain is based on the prefix. So in this case, it's a hept. It's a heptene. But now I need to identify the location of the double bond. And the location of the double bond is closest to the beginning of the chain. So in this case, the double bond occurs between carbon 1 or 2 or between carbon 6 or 7. So we're going to call it, it's going to be we number the chain from the 1, 2 position. So we're going to number it closest to the beginning of the chain. So I'm going to call this a 1-heptene. Okay. And then the third type of compound that we're going to talk about is the triple bond. It's an alkyne. So I'm going to tell the world it's a triple bond by putting the INE or the YNE ending. That tells me that it's a triple bond. I'm going to number my carbons 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So it's 5 carbons long. So I'm going to call it a pent. So it's a pentyne, and we have to tell the world where the double bond is located, or in this case, the triple bond is located. And the triple bond is located either between the third and the fourth, or the second and the third. So we're going to call it a 2-pentyne. So that's the basics of how we name straight chains or hydrocarbons. So here's some more practice, and I'm going to kind of walk through these with you so that we can kind of talk about it. But you're going to see that, like in the case of 6A, which is the first one I'm going to talk about, I know that there's all single bonds, so it's going to be an A and E. I know that there are 1, 2, 3, or 1, 2, 3 carbons, so it's going to be a prop. It's going to be propane, and that's it. We're done. There's nothing we have to worry about because there's no multiple bonds, so we don't have to tell the world where they are. For the 6B, we have a double bond present, so we know it's going to be. So we know it's going to be an alkene, and now we do need to number the carbons: 1, 2, 3, 1, 2, 3, and the double bond has to occur between the first and second carbon, or the second and third carbon. Should be the beginning of the chain, so we know it's going to be probably a 1. And in this case, the prefix that we're going to use is prop. So it's a 1-propene. Okay, now moving up to the top ones. Up in the top ones, we have these things here that are called branches or substituents. I believe the reading called them substituents. Hang on a second here. Okay, so they're branches or substituents, and branches or substituents are named for the number of carbons that are present. So in this case here, the number of carbons that are in the branch is 1 carbon long, and the prefix for 1 carbon long is meth. But because it's a branch, we're going to call it a methyl. Okay. Now, in this one, it is a 2 carbon long branch. And the prefix for 2 is eth, and because it's a branch, it's an ethyl. Okay, so when I go to name these carbons, for number 4, for example, there are 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. So the rule is just like with identifying number of bonds or types of bonds. This is an alkane because it's all single bonds, and it's 7 carbons long, so it's a heptane. Okay, but then there's a branch. Now the rule for double bonds and triple bonds is that we count closest to the beginning of the chain, and the same applies for the branches. So in this case, my branch is a 1 carbon long methyl branch, and it's methyl. Okay, and we still have to tell the world where it is, and it should be closest to the beginning of the chain, so it is a 2-methylheptane. Okay. For number 5, we still have to identify that it is all single bonds, so it's an alkane. We're going to count the carbons: 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 carbons long, so we're going to call it an oct, like octane. And on the 5th carbon, there is a branch that we already identified to be an ethyl branch. So I'm going to put the suffix for branches, which is ethyl. And then I'm going to identify that it's 2 carbon long, so it's ethyl. So it's an ethyl octane. And we have to tell the world where it is. And so because it's located, the branch is located either on the 4th or the 5th carbon, we're going to count closest to the beginning of the chain. So it's a 4-ethyl octane. So when you name them, what you have to do is you have to go ahead and identify the longest continuous chain. And generally speaking, when I try to identify the longest continuous chain, what I do is I try to go ahead and highlight as long as I can go. So in this case, if I went 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6 again, right? 1, 2, 3, 4, 5, 6. I lied. Let's try that again. So 1, 2, 3, 4, 5, 6, 7, 8. It looks like 8 is going to be my longest continuous chain. And so the chain does not necessarily have to be straight, but it does have to be the longest continuous chain. So in this case, I know that it's an alkane because there's all single bonds. I know I'm seeing some branches here. So I see there's a branch here, there's a branch here, there's a branch here, and there's a branch here. Each of these is 1 carbon long. And each of them has, so it's a 1 carbon long, so it's a methyl branch, and I have 3 of them, and then I have a 2 carbon long, and that's an ethyl branch. Okay, so when I go to name this structure, I know it's an alkane. It's 8 carbons long, so it's going to be oct. So it's an octane. I'm going to count my carbons now. So 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. So I've counted them, and I'm going to note where the branches hit first. So going from left to right, I get a branch on the 4th carbon. Going from right to left, I get a branch on the 3rd carbon. So I'm going to draw this structure going from right to left. So now I have 3 methyls, and I have 1 ethyl. And the other rule about branches is we have to put them in alphabetical order. So the first thing I'm going to do is I'm going to identify my my methyls. So there's a YL, and they're methyl. Okay, and then the next thing about it is we have to tell the world that if there's more than one, we have to tell the world how many there are. So we are going to identify the fact that there are 3. So it's going to be a trimethyl. And we have to tell the world where those 3 are. They are on the 3rd carbon, the 3rd carbon, and the 5th carbon. So it's a 3, 3, 5 trimethyl. And then we have to tell the world where the other one is, the ethyl. So that's YL, and it's an ethyl. And as a result of that being an ethyl, and it lands on the 5th carbon, we're going to call it a 5-ethyl 3,3,5 trimethyl octane. And that's the entire name for this guy. Trying another one. In this case, I see that there's a double bond. So the first thing I notice is that it's going to be an alkene. Okay, and so I'm going to go ahead and I'm going to highlight the longest continuous chain I can find, which is 1, 2, 3, 4, 5, or 1, 2, 3, 4, or 1, 2, 3, 4, 5, 6. So I'm going to say that the longest continuous chain is 6. So it's a hexene. Ooh, E. Ah. So I'm going to say that the longest continuous chain is 6. So it's a hexene. We do have to tell the world where that multiple bond is. So I'm going to start counting 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. And it appears that the multiple bond is appearing between the 4th and the 5th, or the 3rd, the 2nd, and the 3rd. So I'm going to count from left to right. So that's going to give me a 2-hexene. I see that there's a branch here and there's a branch here. They are both 1 carbon long, which makes them methyls. Okay, so I have to figure out, since I'm going from left to right in this case, because of the multiple bond, I now need to tell the world where my methyls are. So I have a methyl, and I happen to have 2 of them. So it's going to be a dimethyl, and they are located on the 2nd and the 4th carbon. So it's a 2,4 dimethyl 2-hexene. Yeesh. And so now the last thing we need to do is talk about drawing hydrocarbons. And I've kind of done this one for you, but I'm going to walk through it. The first thing we do is we look at our name. When we look at our name, we look for the types of bonds. So the ane tells me it's all single bonds. Pent tells me there's 5 carbons. Methyl tells me it's a 1 carbon long branch. The di tells me that there's 2 of them, and the 2 and the 3 tells me the location of them. The YL tells me it's a 2 carbon long branch, and the 3 tells me the location of it. So because I'm drawing the chain, and I know it's 5 carbons long, I'm going to start with my longest continuous chain of carbons, and I'm going to go 1, 2, 3, 4, 5. And because again, I'm drawing the chain, I'm going to number from left to right because that makes it, my head, a little bit easier to figure out. And then the next thing I'm going to do is I'm going to go ahead and I'm going to add my branches. And since I numbered from left to right, I know exactly where to put them. So I know that there's a branch of methyl on the 2, and I know there's a branch of the methyl on the 3, and I know there's an ethyl on the 3. So that's what I did. And then the next thing I have to do is I go back and once I've drawn my branches in, I go back and I add the hydrogens around everything to make sure that all carbons have 4 bonds. So this carbon has 3 hydrogens added. This one's going to have 1 hydrogen added. This one's going to have 3 hydrogens. This one's going to have no hydrogens, 3, 2, 3, 2, and 3. And then everybody's happy. And that pretty much covers how we draw basic hydrocarbons.